Welcome. So this is part one of a tutorial focusing on the course project developing a battleship game. The project description is fully posted into ELC, so I advise you to read it and read it in details. Part of any software development, developing a software application is basically to understand the requirements and elicit the requirement from the client when you're developing an application for a client. In this example, and all of the examples in the course, the requirements are given to you in the textual description. So the very first step is to read this description in details to really understand what's all about. What I'm going to do now, I'm going to go briefly over it. Um, so this game should be familiar to most of you, and basically it's played with two players, and those two players start by placing some ships on a board. There are two boards. Each player has a board, and then the players will alternate into guessing and trying to aiming onto each other's board until hitting or sinking all of the ships. Now the ships differ in their shapes and how many cells each one contains, and in the standard battleship game, I think there are four ships. To make this game more interesting, I'm assuming we've got ships, seven ships that have Tetris shapes, and those shapes can be flipped and rotated, right? So this results in a more interesting uh, uh, board and combination of ships on the board. Now, in this particular example, it's asking you to develop a game which is played against the program, against the computer, right? So one player would be a human player and the other one is the program. So you have also to keep that in mind. Of course, this is a text-based application, so the board will be printed out and the input will be taken by entering the coordinates of the ships or the the missiles targeting the ships from the keyboard. Well, here's, for example, a sample run, and as you can see here, it starts by asking the player to set up the pieces. It gives the player an option to set each piece and an option also to rotate the piece. So if they decide to rotate the piece by entering -1, the ship is rotated and then they enter coordinates. For this example, to 1, so the ship is placed in um, column row 1, column 2, so it's asking for column and row. And this goes over until all of the ships are properly placed. Of course, the program needs to ensure that the values entered are valid and prompting the user to re-enter coordinates if the entered coordinates are not valid. So this is very similar to the tic-tac-toe game we developed in class, but of course it's much more complicated because we have a larger board and many more different pieces that will go inside it. So this same thing happens here, and well, the game starts. Of course, the computer will set the piece on its own, and then the game starts. Now, to simplify uh, playing the games, I'm asking you to print the other player board. Of course, if you're playing this game for real, you don't see the other player board, right? It's hidden. I'm just asking you to do this so that when I test your code, I can easily see if it's working correctly or not. So in this case, you can see that it's showing my board, it's showing the other player board, and that's deliverable 1. Well, deliverable 2 is basically playing the game, and playing the game, the players will alternate. The human player will enter coordinates, and the computer player will basically pick coordinates on its own, and it will show on the map whether this is a hit or miss. So if I enter at 1 1 here, and the AI, the computer player, aimed at 9 0, we end up with 2 misses, right? There is nothing in my board at 9-0 and nothing at the enemy's board at 1-1. And then the games go on and on. Of course, at some point it's going to hit, a ship. So with some hits, until one of the players sinks all the ships of the other player. Okay, so that's the game in a nutshell. Now, of course, this is a much more complex application than the ones we've um, been working on so far in the course. So the first question that comes to mind is, where do I start? Because there are so many things going on. There are ships and board and players and hits and misses and all of these. And I'm going to present uh, my own way of uh, incrementally developing such a large application. Of course, there are multiple ways you can address such a problem. My preferable way is to divide and conquer, basically to start thinking about the high-level implementation, the different parts and pieces, and finish by thinking about the details. So think about constructing a house. When you want to construct a house, you don't think about the interior room design of the rooms. You start thinking about the big details, the layout, the floors, the different rooms, and how they're connected. And you think about the final details and the final finishes and touches at the end. So I will take this as an analogy and I'll try to think about the details of this problem in kind of high level before trying to finish or work um, and finalize the details. Now there are 2 caveats to the discussion. First of all, I'm not going to provide a complete solution. I'm going to leave some stuff out on purpose, of course, because you're supposed to finish it on your own. So take this presentation as a guide. The second caveat is that there are things that can be done more efficiently, but we haven't covered the content related to that more efficient implementation so far. So what I'm going to do, I'm going to assume that the only thing we know is whatever we covered from chapter 1 to chapter 8 or 7 and 8. And of course, there are things that can be improved down the road when we talk about other concepts. So just keep this in mind, that this is not the best or the most perfect implementation, but the logic, the steps of going through it is representative of how you want to address a large task, a large application. Okay, so what I'm going to do, I'm going to start thinking about what do I need in my program? What are the elements in this game? And the way you can think about this is very similar to how you think about creating a database. When you think about the entity relationship diagram, you think about the entities. Those are the things you care about in your application, in your database from a data perspective. So part of the thinking is very similar here. You need to think about the entities, the things you care about. And the difference in here compared to databases is that you care about those things both in terms of storing data about them, but also about incorporating or implementing their actions, their behavior. But the first step is the same. Let's think about the entities here. What do we have here? So reading the textual description of the project, some candidates for entities, and our entities will be classes here, are nouns. So let's read through. We've got goal of the project is to develop a 2-player game, a battleship game. So this is a hint that probably we care about storing information about 2 players, game. Of course, the 2 players may have be human or computer. So this is a hint that a player may have an attribute or a property, a field called type, and type would be either human or computer in this case, right? So you keep reading in, you see that it's talking about a fleet of ships. So there's this idea of fleet, maybe ships, and those have positions on a rectangular board. So um, again, I'm just kind of trying to think conceptually and dump the information. Of course, you've got ship. The ship may have a position. How about board? Probably we care about representing boards. And the board is rectangular, right? So it's storing some information inside it. And then the two players will alternate shooting on each other's lead, so on and so forth, right? So this is like a very basic first pass, but at least you can see that some stuff is becoming clear here. We know, a couple of things that we care about, and we know some information about those entities that will reflect in classes. Now, what helps here is to think about, again, this from a data modeling perspective before trying to think about the remaining details. So let's think about how those different entities are associated. Well, we can see that a game has two players, right? Because this game, a battleship game, has two players. So this is akin to saying that a game is associated to player, right? And this is kind of a crowfoot annotation. So basically, I'm saying that the game has many players, two players in this case. And let's think about the relationships. So pause for a minute and think about a couple of other relationships that you can detect from this textual description. So let's think about the remaining classes or entities here. How about a player? What does a player have? Of course, we uncovered the type of the player, which is a human or a machine in this case. But each player, as the text implied, had a fleet of ships, right? So a fleet of ships is kind of like saying there is a couple of ships that the player own, right? So this is akin to saying that there is an array of ships or multiple ships, right? And conceptually, this is saying probably that the player has multiple ships. And of course, when it comes to being implemented, those will be attributes. So like here you get a game has a player one and player two kind of idea. And same here, you can imagine that it's implemented with a collection like an array. So the player has multiple ships. What else? How about board? How many boards do we have in this game? Well, if you take a look at the sample run here, you can see that there are two boards. There's a board for each player, right? So this is what we see right now, but you have to keep in mind that this is your perspective as a human player. You can imagine that the other player, which is the computer, is doing the same, right? It has two boards, its own board and the other's a player board. So if you think about it, each player basically has these two boards. And this is like also a kind of a relationship here. Because each player knows about its own board, but also knows about enemy's board, right? And because we've got two players, this will imply that we've got four boards in total, right? Of course, there are two physical boards, but there's the representation. Your knowledge of the enemy's board is also a board in the game. And if you ever play the physical game, they're actually 4 boards, right? Um, each player is facing 2 boards. If you take a look at the link here, I think probably we will see the 2 boards here, right? Each player has 2 boards, so you've got 4 boards in total. Okay, so let's go back. So it seems that fleet is not an entity. Fleet is just kind of a description of the fact that we've got multiple ships. So maybe I can reconsider this to be not to be an entity, not to be a class. Um, how about board? What does a board have? Well, you can argue that a board has multiple ships, right? So maybe there's a relationship between board and ship in this case. Of course, this is not very clear at this point. I'm just trying to kind of think out the high-level details. Uh, so maybe a board has multiple ships, but um, uh, like an array of ship. Um, but if you take a look again at the sample run, in the beginning, one board has multiple ships and the other board doesn't have anything. And over time, the board will contain some information about, the state of the board, the state of partial information about the enemy's ship, if you hit or you miss, and also contains other information as the places that don't contain ship. So essentially, the board is basically a bunch of cells. The on board, you know the ships, right? But the enemy's board, you have no idea about the ships, and this idea will come later down the road when you play the game, right? When you do some um, shooting and you realize that there are ships here and there, but in the beginning you don't know. So if you think about storing information in such a board, it's basically a rectangular array of cells, and each cell has multiple values, as you can see here. It can be an open C, it can be a definite miss or a definite hit, right? In your case, in the own case, it can be the ship itself. So it seems that we need something else to store. Of course, your own board contains information about the ships, but the other board, the board essentially is an array of cells, and each cell has different values. So I'm going to say here that a board has multiple cells, and probably this is a two-dimensional array of cells, right? So it seems that we need a fourth class here, a class called cell. Now, of course, this can be a bunch of characters like in the tic-tac-toe game, so it's not a new class, right? It can be its own class if you want to incorporate some extra attributes or methods. At this point, we're not sure, so I'm gonna keep it as cell. I'm not sure what I'm going to store inside cell at this point. All right, so we're trying kind of to map out the kind of the overall entities we care about in this game. We've got one game. The game has 2 players. Each player has a type and a bunch of ships. It also has 2 boards, its own board on which the ships are placed. But it also has a board which is a representation of the enemy's board. We're not so sure about ships yet, but it looks like they have a position and they have a shape, a certain shape, right? If you take a look at those different ships, they come with different shapes, and probably they have an orientation depending on how they are rotated, so on and so forth. So this needs to be fleshed out at some point. And then we have the board, and we have 2 candidates of designing the board. One of them is to think about the board as a big collection of ships. This only applies to own board. It doesn't apply to the enemy's board because you don't know the ships beforehand. So it seems to me at this point that we can represent the board by just looking at the cells and keeping the ships um, known to the player, right? Because I don't want to create a redundancy. Again, some of those details, I mean, this specification is tentative at this point, but it's just thinking about the details for the future. All right. So again, this is very similar to uh, a data modeling exercise. I'm just thinking in terms of entities and what they contain in terms of data, right? But of course, it's more than that because you're not only interested in storing information about the game, the state of the board, and so on. You're interested in providing the logic that brings this game to life, right? So this is a very similar exercise, except that when you read the description, you need to look for verbs. What kind of actions and behavior this game provides, right? So again, let's read through it again and see what we can extract from this description. Also, the two players alternate shooting on each other's fleet. So we've got this verb of, so I'm just thinking in terms of action, alternate, shoot. Okay, so those are some of the verbs. Manages to hit all the other ships win the game. So maybe there is winning, losing, or I think there is a draw situation because you got a one last shot, so it's possible to end the game in a draw. Um, let's read through asking the user to enter their name, asking them to enter position on the ship, on the board. So place ship on board, enter name. Those are some tentative actions. Um, so giving the choice to rotate piece, each piece, rotate piece, right? Computer places the ship, the game begins. So there is this idea of game begins, game proceed, players taking turn, and so on, right? So, I mean, of course, some of them are very tentative at this point, but let's think about how those actions map to the different entities or the different classes. So when we say that the two players alternate in taking turns, you can think about alternate as a method. Where does this method fit in? Well, the method fits in wherever we have information about the two players, right? Because you want the two players to take turn. Now, if you look at the um, um, kind of the skeleton of the classes here, where do I have information about the two players at the same time? Well, it's in game, right? So probably alternate should be in game because game is the only place that we've got information about the two players, right? How about shoot? Okay, a player shoots on another player um, aboard. Where is this supposed to be? Well, it seems that this is pertained to the player himself or herself. So I would put it in the player as a method in player here, right? So I'm just going to put parentheses here to, of course, it may take parameters, but to emphasize that this is a method. How about win, lose, or draw? What is the best place to detect when the game has ended? Well, it seems that this is something that relates to the game, very similar to the tic-tac-toe, because the game has information about the two players. So tentatively, I'm going to put it here. Similarly, enter name, place ship on board, and rotate piece, and game begins. I would say those are all kind of related to game at this point. Now, of course, when we think about the details, it helps to think, to go through this exercise multiple times, and also to go through that sample run and see what kind of actions are being involved, right? And through this exercise, you can figure out that there are probably more potential or tentative methods that you may want to implement or care about. So I'm going to leave this as an exercise to finish part 1, and I'm going to proceed in part 2 by trying to sketch out the general implementation and trying to kind of create these entities as classes and think about how we proceed with the implementation.